I mean, I have questions on the homework.
Okay, nothing in the reading guide?
No.
Yeah, it's a pretty short section. All right, go ahead, ask away, ask your questions. 4.5.
Can we do number 9?
Number 9. All right. All right, go ahead, read it.
It says, here's Marco's method for calculating 38 times 60. 4 times 6 is 24, so 40 times 60 is 2400. Then 2 times 6 is 12, so it's 2400 minus 120, which is 2280. Write equations that incorporate Marco's method and that also show why his method is valid.
Okay. All right. Do you have a sense? Are you completely stuck or partially stuck? Let me ask you that.
I'm not really sure.
All right.
I was just kind of confused on what he was doing.
What he's doing. So go turn, like, can you do the problem? How would you do it if you had to do it? So we have 38 times 60, right? How would you do it? So
I'd probably just use a calculator.
oh yeah, no calculator. If you had to do it without a calculator, how would you do it? So look at it right now. What do you think you would do? Nicole?
I don't know.
No, I don't know. You know how to do things. Come on, try something. No calculator though. Can't use a calculator. No, I don't know is allowed. How would you go about doing 38 times 60? Is there one of the problems that you can easily do? Remember, you're trying to make it easy for you.
Can you split up 60?
Okay, how would you like to split 60 as?
30, wait.
30
times 2?
All right, we can do 30 times 2. Okay, that's a good start. Keep going. Now what? That's a good split what you made there.
Now I don't know.
No, you do. Just go with instinct. Sometimes when you encounter a problem that's difficult, your brain just shuts down. And don't do that. Just go with your instinct. You have a really good start here. Keep going. Don't worry about what this person did. Just do what you want to do. Remember, you're trying to make it easier for yourself.
Split up 38.
All right. How would you like to split up 38?
19.
19 times what?
Times 2.
Times 2?
Yeah.
Okay. All right. And then we still have this. Remember, you're trying to make it easier for yourself. Keep going. Now what? So let me ask you this. What you just did here, is it easier or did you just make it even more hard?
I mean, essentially it's the same problem.
It is the same problem. So
do anything.
That's correct. You can't do anything here. So go back. This is a good start what you have here. How can you use this to your advantage? Tell me why you did 30 times 2. What makes that easy? You are correct that 30 times 2 will make it easier. What is it about 60 that 30 times 2 will make it easier? Like in your head, why do you think a person could have chosen that?
Because 30 is a smaller number.
Yes, very good. Not just smaller number, but it has a 0 in it. Is it easy to multiply by like 10, 20, 30, 40 like that? Is that easier?
Yes.
Because you just stick a 0 and then you just multiply by 3 or 2 or whatever, right? Okay, so 38, if I know that it's easy for me to multiply by zeros, then 38 is closest to which 0? 10, 20, 30, 40. Very good, 40. How can I write 38 as? 40 times what? Or 40, how can I use 40 to get 38?
40 minus 2.
Good for you. Okay. So now I have 30, we can just keep our 60 as is. So look at what we have here. This would be easier. Would you agree with that, Nicole? Because you said multiplying by zeros is easier. Yes?
Yeah.
Yeah. So what property will allow me to finish this problem then? Keep looking. How do I multiply this times this? What would I do?
Distributive property.
Very good. Go ahead, do it. Tell me what to write. You can do it. You said distribute, right? So go ahead and distribute the 60 in. So what will it look like? You can do it.
I don't know.
Yes, no. You just told me what to do.
I'm not sure.
Oh, no, you're sure. What should I do? In fact,
can I phone a friend?
No. So let me draw a picture. Maybe that will help you here. So we have 38 times 60 equals 40 minus 2 times 60. And you said, I want to use distributive property. Distributive property means what? What is a distributive property? Can you tell me that? Is it like that?
Yes.
And then once you do that.
Wait, so would you do 40 times 60 and 2 times 60?
Yes, you got it. Okay, so tell me what to write.
40 times 60?
Yes. Okay.
And then minus 2 times 60.
Very good, minus 2 times 60. Ooh, hold on just a second. I forgot to record. Hold on. Okay. All right. So remember, your instinct was to say, I do not know, but you do know. What is it? You just multiply from, I'm just going to finish drawing the arrows because in case somebody, this is the kind of writing that you will be doing on exams. And also draw arrows properly so that people can see what you did. All right, keep going. Now what? Oops, hold on. My arrows moved. All right, go ahead. Now, you said.
Now you do 40 times 60.
Yes, very good. How do you do 40 times 60 easily?
24 with 2 zeros.
Aha. Keep going.
And then 2 times 60, which is 120.
Look at you. That's what made it easier to compute, isn't it?
Yeah.
All right. So how do I do 2400 minus 120? Go ahead, do that for me. So it's 400 minus 120, right?
400. 2400?
Yeah, 2400, but the 2000.
1200?
Say again? No, look. Oh, why 1200?
Oh, I don't know.
No, so look, if I want to do, so here's a question to you. I want to do 2400 minus 120. What could I rewrite that as to make it easier? What is 2400? It's 2000 plus 400, right?
Yeah. So
okay. So 2000
so you could do
plus 400 minus 120, right?
Yeah.
Okay. Tell me what to write then. What is? So 2000 plus what? 400 minus 100 is 300, right?
300.
And 300 minus 20.
280.
Look at you. So what's the final answer then?
So 2280.
You just did the problem. So you just did the problem. You can see how to make it easier. You have to get in groups of 10s, yes?
Yeah.
All right, now read what he did, because maybe it will be easier for you to see what happened. Go ahead, read what Marco did now. So let's write here Marco's work. So go ahead and read it, and we can write it in a way that it becomes easier. What does it say?
He did 4 times 6 is 24.
Okay, so let's write that. 4 times 6 is 24. Okay, what else?
So 40 times 60 is 2400.
So 40 times 60 is 2400. Okay, then what did he write?
Then 2 times 6 is 12.
2 times 6 is 12. Okay?
So it's 2400 minus 120.
2400 minus 120, which is 2280. Look at his work and look at your work. Is there any similarity at all as to what you did and what he did? What do you think?
Well, yeah.
Yes,
So
which
40
part?
The 40 times 60 part is right.
That's correct. And then you also had 2 times 6 or 120. So is there anything you could have recommended? What should he do here? It should not be 6, but what?
60.
There you go, 60, which will make it 120. And the way to write would be what you just did right there, isn't it?
Yeah.
Yeah. And he did all of this work in his head, so we can get rid of it and say that. That's what he did, basically.
Yeah.
Okay. Can you see how sometimes when you don't understand what a student did, what you can do is simply solve the problem your way and then see what is happening to the student's work. And it's possible that after you did the problem, it will become easier for you to see what the other student did. Does that help?
Yeah, that helps.
So remember, your instinct was to say, I don't know, but that is not correct. Don't do that, because you do know. And even if you didn't know, what's the worst that will happen? You try and it's not correct, and that's what we're here for, to discuss it, okay? I need you to develop more confidence there, Nicole. All right, anything else? Any other questions on 4.5?
Could we go over 17?
Alrighty. So let me ask you a question. Are you completely stuck or partially stuck?
Completely stuck.
Completely stuck. So when you are completely stuck, let's give you some strategies on how to come out of it. So go ahead and read problem number 17. Let me first get it here. Oh, it's a long problem. Okay. All right, go ahead.
There is an interesting mental technique for multiplying certain pairs of numbers. Following examples will illustrate how it works. To calculate 32 times 28, notice that there are two factors, 28 and 32, are both two ways in opposite directions.
Like one of them is 30 plus 2 and the other one is 30 minus 2, right?
Yeah.
Okay.
To calculate 32 times 28, do the following. 30 times 30 minus 2 times 2 equals 900 minus 4 equals 896. Notice that you can do this with a calculator. Do this calculator in your head. Similarly, to calculate 59 times 62, notice that they're both factors are one away in opposite directions from 60. And 59 times 62 is 60 times 60 minus 1 times 1 equals 3,600. Minus 1 equals 3,599.
Yeah.
Once again, notice that you can do this mentally.
Okay, so let's use that method. So let's do part A. Part A says what? Compute.
Use the method just shown to calculate 83 times 77.
83 times 77, right?
Yeah.
So take a look and see. 83 is how far away from 80?
3.
80 plus 3. And 77 would be 80 what?
Minus 3.
Minus 3. All right. So now remember how Nicole used distributive property. If you use that here, could you tell me what would happen? So you would have to do term by term multiplication. So you would go 80 times 80. You agree with that? And then what else? Keep going.
80. Wouldn't it be like
Yeah.
3 times 3? Or no, 80 times
Well, you have to go term by term. So it will be that, right?
Okay.
Okay. Then what? You also have to do the second number, which is
3 times 30 and 3 times 3.
yeah, 3 times 80. And what was the other one you said?
3 times 3.
3 times 3. All right, let's see. Like that?
Yeah.
All right. So tell me what to write then. So 80.
80 times 80
Okay.
equals
Yeah.
6,400.
Yeah, we'll write that second. Just give me all the numbers that you just spoke. Minus 80 times 3, you said, plus 3, oops, plus 3 times 80, and then minus 3 times 3. Okay. I'm going to press enter here just so we can see it here. Okay, you see that?
Yeah.
All right. So go ahead and tell me what to write now.
Well, 80 times 80 equals 6,400.
Okay.
And then 80 times 3 equals 240.
Okay.
And then you'd have to write another 240 because it's 3 times 80 again.
Very good.
And then 3 times 3 equals 9.
Yeah. Perfect. So look at what happens to the middle number. This.
They cancel out.
Yes, very nicely done. That is why that method works. Can you see that?
Yeah.
So your answer would be 6,409. Oh, no, you have to subtract. So
no, you have to subtract
301.
6,391.
Yep. Perfect. But do you see why it works?
Yeah.
Okay, why does it work? Would it work for any number?
Yes.
Yes, it would. As long as what? This number and this number are identical.
Okay.
So we can color code it so that you can see. So now I ask you this then. What if I ask you to do A plus B times A minus B? What do you think the answer should be then? It will be A times A, which will give me A squared, right? Okay. Then it will be minus A times B plus A times B, which will disappear. And you'll end up with minus what?
Minus B.
Just B or B squared?
B squared.
B squared. Could you show this to me in a picture? Could you draw a picture to show me that? And this applies to everybody, not just her. So I want everybody to take a moment, and we will do this as an attendance quiz. So go ahead and draw a picture that shows me how this is visually. So A plus B times A minus B. That's what I want you to show me. Draw a picture. A rectangle would be A plus B. So go ahead and see what happens. Go ahead, see what happens. Let's do this as an attendance quiz. I'll give you a few moments. Everybody understand what I'm asking you to do? Yes, no, what? Who said no?
Nicole said no.
Nicole says no. So what kind of rectangle would have length A plus B times A minus B? How could I show that?
I don't know.
well, a rectangle. So you have to get a rectangle first. So let's get a rectangle here. Here's a rectangle. So here's A, and here's B. I'll make B a different length just so we can see. So right now, oh, and actually we need to make it shoot. We need to have a square. So we'll say insert rectangle. All right, here's my square, A times A. Here's my rectangle, B times A. We'll make this a different color so that you can see what's going on. So the length from here to here is A plus B. Can you see that? Nicole?
Yeah.
From here to here it's A, from here to here it's B. From here to here it's A, but I want A minus B. So I will take this and do what with it? Well, if I add it, it will go down here. If I subtract it, it has to come out of this. So we will have to make that white, just so you can see that it's taken out. Can you see how I took it out?
Yeah.
All right. So now, once I take it out, right now, what kind of shape do you see? Do you see a rectangle or do you see a weird shape? Because look, right now I'll start here, 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 up and over. This is gouged out of it. Can you see that?
Yeah.
All right. So how can I make a rectangle out of it? That's the question.
Okay.
Okay. So go ahead and tell me what I should redraw that as. A better question would be, I'm going to pull this piece out here. Oh, actually, I need.
So whenever you say like draw it, do
Yeah.
you mean like a rectangle like this, or could you use
Strip diagram.
Like, lattice grid too?
So tell me, what did you want to do?
So how I always was taught to do this was they had us do lattice grids.
Yes, that's a little bit different. Right now, you're just trying to show. So could you draw it for us? How would you draw it?
Yeah, here, I'll show you what they had me do.
All right. So here we have A times A. Here you have B times B. Can you see how this is A squared minus B squared? Can you see that? Can everybody see that? Let's make that white so you can see that. So A squared minus B squared is this, which means I have this piece here, and I'm going to take this piece and this piece here. These are actually filled in because they exist. We didn't take those out yet. How can you rearrange it so that it becomes a rectangle? I can take this piece and move it here. And then gouge it out of the bottom. So we'll make that white. So now we have a rectangle. This length is A minus B, and this is A. Oh, this should still stay blue. This is A plus B. You can see how this bottom piece is sitting up here. Nicole, can you see that? A plus B and A minus B up and down. That's the picture showing you A squared minus B squared is A minus B times A plus B. All right, let's make Jamie a presenter so she can show us what she drew. So let me stop sharing here. And then Jamie, I'm making you a presenter so you can share.
So I'm just gonna share what I did on my page. So the way I was taught this, it's really similar to what you guys were doing, where it's still like a plus b on top and like a minus b on the side. But instead of like drawing it out, you just like multiply it, and then you can see the like terms and everything, and then take out as needed.
Oh, this is interesting. A plus B.
So this is how I
A
was
minus B.
So there's still the a plus b on top, and there's still the a minus b on
Except
the side.
that, why should we?
Like b times a.
But that's so what the picture that you just have here is not what you're showing is the algebraic. What you just showed is here. Let's go back and share. What you just showed is A times A minus A times B plus B times A minus B times B. That's what you just showed in your picture.
Mm-hmm.
Do you see that? So in other words, instead of writing it like that, you just put the values in here. That's what you did. But my question is not this, but my question is how does it make sense as areas? So for areas, you're taking this rectangle here. Let me make this rectangle colored purple. And let's make it thicker so you can see the original rectangle. Can you see the original rectangle? This one?
Yeah.
Okay. So this is a squared minus b squared, which is this little portion here, which we will color orange or yellow. And this we will color green for now. I'm just going to move these pieces out of the way so you can see what's happening. A squared is the green square. Let me move this. Everybody see how this is a squared? This green square here is a squared. Everybody okay with that? Yes, no, something?
Yes.
Yes? Now, once you have a squared, oops, sorry, hold on. Okay, a squared minus b squared. B squared is this little piece. Can you see that? I want to take this piece out of here. If I want to take it out of here, that means it will be gouged out. Can you see that? This is what it means to take away b squared from a squared. Can you see that?
Yeah.
Okay, so now look, I have this piece here, which I'm going to take from here. When I take white, that means I took it from there, and I'm going to place it somewhere. This is a piece. Let's make it come forward. Okay, hold on. All right. Can you see how this green piece, I'm going to remove this piece, and I am going to move it here. I'm going to take it from here, turn it, and place it here. Can you just see what I did? This is the piece that came from down here and is placing up here. So now this is all gone, and I have a rectangle. The length from here to here is a plus b. The length from here to here is a minus b. Can everybody see why a plus b times a minus b is a squared minus b squared in the picture? Any questions there?
I don't have a question, but Alicia wanted me to tell you that she's off because her internet is being a pain.
Oh,
I
see her here. Here she is.
I'm here now, but yeah, it's been in and out, so.
Okay, so if that ever happens again, there should be a telephone number by you. It should say 1-800 whatever, so some number. Go ahead and give that a call, because that way at least you can hear it.
Oh, okay.
Okay, so do you see the number? It should be up there somewhere.
No.
No? Let's see. It should be there. Here, it says use. Okay, do you see the little wheel on the bottom right?
Yeah.
Click on it.
Yeah.
And then there should be a use your phone for audio.
Oh, okay.
And then you can call that number, and that way in the minimum, even if your internet goes out, you can hear us.
Yeah. Okay.
Okay.
This is right now.
But it looks like you're here right now, so that's good.
Yeah.
Okay.
Yeah.
All right. So I know, plus I'm recording it, so you'll have the recording for the visual if you miss it.
Okay.
Okay. But everybody understand what I mean by drawing a picture, visually understanding why a plus b times a minus b is a square minus b squared. Everybody okay with that? Questions there? All right, so.
Just making sure.
Yeah.
Would a plus b be on the top and then a
Yes.
minus b on the side?
Yes,
Okay,
very good, very good.
Sorry, which one?
Yep, is that Sarah talking?
Yeah.
Good for you, Sarah. That's awesome. Very good. So
Thank
we should
you.
probably label it. So let's
Yeah.
go here and label it. So from here to here. Yeah, so from here to here you said is, and from here to here is A, and we took away the B, so just right there, and insert. So that part here would be A minus B. Make it a little bigger. And the A plus B would be here. Does that help?
Yeah.
Yeah. Okay, very good. So that will allow you to do then 195 times 205. Will you be able to finish part A then? Who was the person who asked the question? Was that Sarah? Was that you who asked the question?
Yeah.
Okay. Will you be able to finish then the 195 times 205? Yes, no, something? Go
I'm
ahead.
trying to find it.
Yeah, go ahead. Oops, hold on. Somehow this came out of here. I think Autumn might be having trouble also. I see her going in and out also. All right, go ahead. Tell me what to write.
I'm trying to find, where is
Oops,
it?
hold on just a second. All right, so the next numbers are what? 195 times 205. So what should I write here? Instead of 80, you would have 200 minus 5 and 200.
Oh, and then 100 minus 95.
Say again?
And 100 minus 95?
No, you mean 5? Don't you want 200 plus 5 and 200 minus 5?
Oh, I was looking at 195 for a bit there.
Yeah, but 195 is closer to 200, isn't it?
Yeah.
Yeah. So it'll be 200 squared minus 5 squared. which will be 4, 1, 2, 3, 4, minus 25. All right, tell me what to write. How much is that?
That's 39,975.
Yep, very good. You got it. Were you using a calculator?
No.
Okay, just checking. All right, that's good. Okay, then part B says now explain how it works. Draw a picture, which we already did. Right? Are you okay with that then?
Drawing a picture like we just did there?
Yeah, like above here. Like right here. You okay with that?
I could try.
And otherwise, you can rewatch the video and draw the picture from there.
Yeah.
Yeah, it's this picture that we just drew right here. And we labeled A plus B, A minus B. That's your picture, basically.
Okay.
Okay. And you can even draw an arrow to point that. So we can say this basically went there. Can you see that?
Yeah.
Okay. All right. Any other questions on 4.5? Otherwise, we move on to 4.6. Anything at all?
Can we just go over like how you identify which ones like the associative properties?
Yes.
Because in
Yes.
Because
So
it has to go through like in most of the problems, it has you like write down the equation.
Yep. So pick one and then we will do it.
Associative, and I guess I always get a little confused about
So
that.
associative means when you multiply, like for example, what property did we use here? That was distributive property of multiplication over addition, right? So distribute means you are distributing. Associative property. So when you do associative, I'll just go to the next page. So otherwise it will look like, I don't want it to be, oh, shoot. This is part of the picture here. All right, associative property. Tell me what associative property is. Like if I have A times B times C, and I rewrite that as parentheses A times B times C. So if you have all multiplication problem and you change the order in which you multiply, instead of multiplying B and C first, you multiply A and B first and then C. That's associative property. And don't just say associative property, say associative property of multiplication. Can you see that, Jamie?
Yeah.
Okay. When would it be commutative property? Commutative.
Isn't that when there's no parentheses and it's just like?
So that would be, that is correct. And so that would be A times B equals, when you change the order in which you multiply. Instead of A first, then B, you multiply B first, then A. If you used both, properties, both associative and commutative property of multiplication, how would it look? So let's take this.
Oh, that's a lot, Shivangi.
I know, but that's what happens in some of them. So, so you would write, this would be A times. The first thing I will do is change the order. So C times B. Tell me what property I just used.
Isn't that the associative property because there's parentheses involved?
Ah, so look at how you're remembering that. I do have parentheses, but did the parentheses move from the end to the first, or did the parentheses stay exactly where they were?
Oh, they stayed where they were, so
They stayed
commutative,
where they
right?
were. But on the inside of the parentheses, the order changed. Can you see that?
Mm-hmm.
So what property is that then?
Commutative?
Okay, commutative property of multiplication. Okay, now I'm going to rewrite it again, and you tell me what property I just used, okay?
Okay. Now that the parentheses moved, it's associative?
Yes, very good, very good. You got it.
Okay.
Property of multiplication. Okay, now here's a question for you. I'm going to take this, and you tell me how would I get to the following. What property would this be? What property is that?
That is associative because the parentheses moved.
Ah, but
Yeah.
look very carefully. Look at, did the parentheses, so only the parentheses move.
So it's just, oh, I see. So the inside of the parentheses is still the same.
Yes.
So it's just,
so what property?
because you change the order you're multiplying.
Yes. So actually, I have a question for you guys. When I present like share screen, do you see my video or do you just see the file?
I see your video.
Oh, good. Okay. So if I do my hand stuff, you can see that.
Yeah.
So if I have a parenthesis here and a number here, and I just take the parentheses and shift them here without changing the order of what's here, that's associative property.
Mm-hmm.
But if I go from here to here like this, so do you see how it shifted? Everything shifted left, right? Then it will become commutative property. Does that help?
Yeah.
Yeah. So when you write your steps out, you have to figure out what are you actually doing. Are you just changing the like left, right movement? Or are you just lifting the parentheses and putting it in the front? Which means that inside of the parentheses is something different.
So if what's inside the parentheses changes, then it's
no, don't memorize it like that, because you could have, like for example, I could shift whatever is inside the parentheses. Like right now, the parentheses shifted and inside is the same, but here the parentheses inside is different, isn't it? But it's still commutative property. So it just depends on, so you can think of associative property, it's like if you play with dolls, you have two identical dolls and you take clothes from one and put it on the other one. So the parentheses is like clothes. You're removing it from one and putting it on the other.
Oh, okay.
Can you imagine that?
Yeah.
So the parentheses are the decorations. You are removing them and putting them on a different pair. Does that help?
Yes.
Okay.
So the commutative is just when you change the order you multiply.
Yes. But left, right order.
Yeah, left, right order. Okay.
And then associative property means you removed the decorations from one and put them on the other ones.
I like that.
Okay. Any other questions in 4.5? Alrighty. Let's go to 4.6. Are there any questions on 4.6 reading guide? Anything at all? It's a pretty straightforward, like just how to multiply basically, right? Everybody okay with that? Reading guide? Okay. All right, problems. Anything from 4.6 that you would like me to do? Well, first, actually, I have something to do. So I ask you, how do you multiply things? So I would like each of you to multiply the following numbers just for, so I can make sure you know how to do normal multiplication. Let's say 324 times 46. How would you do that multiplication? The standard algorithm. Standard algorithm means that you are going to write that as, actually, let's make this a new page. All right. Standard algorithm means you're going to have to write it in this manner. So I'm just going to make a, all right, we'll merge these together. 324 oh, I didn't want to merge them. 324 and then times 46. So we just don't want the borders around it. Do you remember how to do that? What's the first thing to do then here? How do you do that? Tell me term by term what to do. Anyone?
6 times 4.
Good for you, which will be how much?
24.
24. Okay, then what?
What is it? 6 times 2.
Good, which will be?
12.
12. So do I write 12 or do I write something different? Would I write 12 like this?
Isn't it 120?
Oh no, you gotta carry it. Sorry.
120
So,
you said? Can you tell me why you said 120?
I said that.
Oh,
Because
okay.
aren't you doing like 6 times 20 now?
Good for you. So the 0 is a placeholder for the 20.
oh yeah, yeah. Okay.
Okay. And so keep going. Then what?
Oh,
6 times what?
3.
3, which is
18.
18. So do I write 18 or what?
So it'd be 0, 0, 8. 1.
0, yeah.
Sorry, I'm like thinking backwards. Yeah.
Like that?
Yeah.
All right, then what? 4 times
24 times 4.
yes, so 160.
Yeah.
Okay, keep going. Then what? 40 times 20. Everybody okay with that?
Yeah.
And then what?
Mm-hmm.
40 times 300. All right, so for all of these, you're going to have a plus. Oops. We just need to make sure they're all lined up. Do they all? You add them all. I'm not going to write all the pluses, but you add them all. Give me the answer here then. What should I have? And let's make that
14,904.
Tell me how you got that.
I added it all together.
So here we have, all right, so 4, yep, 4 here, then 4, 10, 0, carry over 1, 10, 18, and 119. So is that what you spoke? Jamie, what was the number you spoke?
14,000.
Oh, you got 14,000.
Yeah.
Okay. 12, 13, 14. Okay, I got it. 14,904. Is that what you spoke?
Yeah.
Yep. Alrighty. I'll take that. Any questions there? This is the standard. Tell me why these zeros are in place here. 0, 0. These zeros represent what? Zeros are used as
the place values.
Placeholders, yeah. Okay, so this is a standard algorithm. Could someone tell me what is the partial product method? What do you think? Is this the partial product method?
Isn't it when you do like exactly what we did, except on the like right hand side you write down like
Yes.
what you did?
Yes.
So like next to the 24 you write 4.
Yep.
Okay, bye.
Perfect. All right. So I ask you, so
Just kidding, okay.
partial product method. All right, so in the standard, however, we don't write all this. What do you do instead? I'm going to take that. We do carryovers. So what would you write here? 6 times 4 is 24. So I would write the 4 and do carryover here. You agree? And actually here, I'm going to see if I can stop sharing that. And let's get a whiteboard here. Can you see the whiteboard?
Yeah.
All right, so let's do 324. And Jamie, you're still the presenter, so I bet you can write. Actually, maybe all of you can write probably. Let's say, let's just do 26. All right, let's see. Jamie, see if you can write on the board. Use a pencil and start multiplying like normal. Like I'm going to show you 1. So 4 times 6 is 24. I'll write the 4 here and carry over the 2. 6 times 2 is 12. 12 plus 2 is 14. So I would write the 4 and carry over the 1. 6 times 3 is 18. 18 plus 1 is 19. And then I would say plus a 0 placeholder for the 20. 2 times 4 is 8. 2 times 2 is 4. And 3 times 2 is 6. And then add it up. So you would have 4. 4 and 8 is 12. So 2 carry over 1. 14
I
carry
can't
over.
see what you're doing.
Who said
Like
that?
nothing's showing up.
Oh, really? You don't see my board?
Like I see just a whiteboard, but nothing that you're drawing.
Oh, shoot. Nobody sees it? Ah.
I see it. I see it.
All right, hold on. Let's see if I can. Autumn, could you see my word?
Yeah.
Okay. Okay, can you see now?
No. But
No.
it's okay. I understand what you're doing.
No. Hold on. I'm going to see if I can share it with you. Share application screen. Okay, what about that? Do you see
Yeah, I
it?
can see it now.
So this is what I wrote on the board basically. Okay? Thanks for speaking up, because if you don't say something, I won't know what's happening. But do you see how we do 6 times 4, 24, 4, carry over 2? Can you see that? Yeah? Can everybody see that?
Yeah, that's what I got the first time. I couldn't understand the other way you did it.
Right. So this is called the standard way. The other way is called partial product. Partial product means you just separated it out. So this 24 is 4 times 6. This 120 is 20 times 6. So partial product really is rewriting it 300. So let's just make it 300 plus 20 plus 4 times 40 plus 6. Can you see how 4 times 6 is 24, 20 times 6 is 120, 300 times 6 is 1800. So these here, let's make them green. This green part is multiplying 6 times all 324. this part here is the same thing, but now it's 40 times all of them. So 40 times the leftover part will be the red part, and then you add them up. DJ, can you see that?
Yeah, it's just too complicated.
Yeah, it's only too complicated because you've never seen it before. But this is.
I have, but at the same time, it was never like mandatory for me to do. So like I never really got used to ever doing it.
Right. Yes, and that's true with a lot of people. Like sometimes you may have seen a method, but you may not know what that method is. So when I say use partial product method, it's really using distributive property and writing it up down instead of left right. That's the only difference. Like, you know how if I were to take, so look over here, let me go here and insert like 300 times 400 would be the 12,000. Can you see that? If I just go with arrows like that, that's what all this is. That's all it is.
So you're just not like using like the numbers and like so you're just like doing them diagonally and then just putting them down instead of like combining them and then
yes,
doing the number.
That is beautifully said. Say that one more time. Everybody listen carefully to the difference between partial product method and the standard algorithm. DJ put it very, very beautifully. Say it again.
So like it's not like just going like diagonally and fitting like for one number all the answers on one line.
Right.
Instead it's just like breaking them all up into like the diagrams and going down.
Yes, that is exactly what that is. In fact, you can see how here 6 times 4, we did exactly what you just spoke. One number for 6 and one number for 20. Whereas here, you have separate numbers for each one, and then you added it all up. Perfect. That is beautiful description of the difference between partial product and standard method. Now, let's see if you know how to do the lattice method. For a lattice method, you will write 324 on top, 26 on the side, 2 times 4, which is 0 and 8. 2 times 2 is 4. We write 0 here, 4 here. We continue like that. And then for lattice method, see these diagonals, you add them up. So here we have 6 times 4, 24. Here we only have a 4, so 4 will go here. Add up all of these numbers, write the number down here, and the carryover goes right there. Add up all of these numbers, write the number here, carryover goes in the next diagonal, and you just keep on going like that. So our final answer is right here.